Circle question 2025, paper 2, section A, question 3. Diagram below shows 3 circles labelled P, Q and R. So write each of the letters P, Q and R in the correct place in the table so that each circle matches its equation. Well, I told you many times in class that any circle with centre 0, 0 and radius R, so radius is equal to R, will always follow the format x squared plus y squared is equal to r squared. Okay, I always told you we'll follow that format for reasons we've done many a time. So that means that these two circles are both your x squared plus y squared is equal to 9. So that means straight away a process of elimination. Circle R there is the one that's not that. We'll go through that again in a second. So one of them is a radius r squared equals 9. And one of them r squared is equal to 1. So this one over here, x squared plus y squared is equal to 9. So that means that the radius squared is equal to 9. Take the square root of this side, you get r. Take the square root of this side, you get 3. So a radius of 3 here, 1, 2, 3. That's circle Q. And the other one has to be, it has to be, even if I do it here, x squared plus y squared is equal to r squared. So x squared plus y squared is equal to 1. R squared is equal to 1. To square root of this side you get r, square root of this side you get 1. And that's p. That's just proving it there, but you should be able to see it off. Now, where does the x squared plus y squared come from? Well, if you ever had a meltdown in the exam, x minus h to be squared plus y minus k to be squared is equal to, y minus k to be squared is equal to r squared. In the exam, if the centre is 0, 0, and I sub in there for h and k, you can see what's going to happen. X minus 0 to be squared plus y minus 0 to be squared. Forget about the radius for a second. And x minus 0 is x to be squared is x squared. Y minus 0 is y to be squared is y squared. And therefore, that's why a circle with centre 0, 0 and radius r. One of these years, you're going to get a question like this. You're going to get something like 4x squared plus 4y squared is equal, 4x squared is plus 4y squared is equal to 16. And all you've got to do is divide by 4, divide by 4, divide by 4. And now you've got centre 0, 0. R squared is equal to 4, so the radius is equal to 2. Watch out for one like that. One of these years they're going to ask one of the, or give you one of those questions. This could be the year. Moving on, part number B. The circle C is centre 3 minus 4 and radius 7. Write down the equation of the circle. So that's h, that's k. You've got your formula x minus h to be squared plus y minus k to be squared is equal to r squared. Set it up. So there's my node to T-Rex. And we start plugging in values. H is 3. Y, I always told you, if you have a negative number, make sure you put in brackets. And R there, simple enough, there is 7 going in there. So now changing that, that's going to be x minus 3 to be squared plus y plus 4 to be squared is equal to 49. Moving on. Next part number C. The circle K is centre minus 1, 3. Okay? The point 27 is on the circle as shown. Find the radius of the circle. I suppose the easiest thing for me here to find the radius is just find the distance from this point to this point. Using the distance formula here, so minus 1, 3. You're going to have 2, 7. There was other ways, possibly even easier ways, but look, this is always a tried and trusted one to do here. So you've got x1, y1, x2, y2. You've got your formula. I'll put it up here so we won't run out of room. The distance formula is equal to square root of x2 minus x1 to be squared plus y2 minus y1 to be squared. That's coordinate geometry formulas. Gives you that in the thing. So we're looking for the radius. That's what d is, the distance. Square root. Set it up again. So set it up. Leave blank here, blank here, blank here for y2, blank for y1 to be squared. Start filling in. So we'll start with our x's. x2 is 2. x1 is minus 1, make sure you put in brackets. And then y2 is 7 and y1 is 3. So only brackets needed if you have a negative number. Then get your calculator, beautiful calculator there that will do so much work for you. Bang it up there, look, let's bring him in here. He's out of play, out of action. Square root of, be careful of your stuff here now when you're putting it in. 2 minus, bracket, minus 11. Sorry, minus 1 even. Yeah, minus 1, and the end of that bracket, that's what it is. Close up the brackets overall, press squared, then plus 7 minus 3, all to be squared, press equals, and you get an answer of 5. Okay, so that's the radius of circle K. Moving on, part 2, hence or otherwise write down the coordinates of 2 points that are on the circle K other than 2, 7. So 2 other points that are on the circle. So what we could do here now, we could do a translate, or let me see, wherever we could, how would we do this? So hence or otherwise write down the coordinates of 2 points that are on the circle K other than 2, 7. So right, we could use a translation to find one of them. That's definitely a possibility here, but here's the way I'm going to go for it. So I'm going to go for x minus h to be squared plus y minus k to be squared is equal to r squared. This might be the right way, I'm just thinking off the top. We know that the radius circle is 5. We know that the centre is minus 1, 3. So now I'm going to get my h and k here, h, k. I'm going to update my circle to give me x minus plus y minus is equal to r squared. I'm going to just, 5 squared is 25. I'm not going to waste any time here. Or no, you know what? I better hunt for sheep as a lamb there. So now putting in, we've got our h is minus 1. Our k is 3 and our r is 5. Tidying that up, we get x plus 1 to be squared plus y minus 3 to be squared is equal to 25. Now, we've got our equation. So, what I'm going to do here is I can see that it cuts here on my circle on here. I can see it cuts here and it cuts here. Where it cuts the x-axis, that means that the value of y is going to be 0. So I'm going to use that fact down below here. Cuts the x-axis, that means that the value of y is going to be equal to 0. So I'm going to put that in here and I'm going to go x plus 1 to be squared, sub in 0 for y. Right, let me tidy this up a bit. I'm going to get x plus 1 squared. Leave it like that, I'll show you a cool little trick. So 0 minus 3 is minus 3, minus 3 squared is 9, is equal to 25. Then leave this on this side again for a second. Take away the 9, we get 16. Now, I've got a squared on one side. I want to get rid of that squared, so I'm going to take the square root of this side. Watch this, pretty cool here. X plus 1 to be squared. If I take the square of this side, I'm going to be left with x plus 1. In fact, you're actually going to be left with, x plus 1, that's fine. But, this is the only time now in your course, you got to watch out for this. You're actually going to get 2 answers here. Square root of 16. I should have maybe put that on the other side, but you're going to get a plus 4 and a minus 4 because you have 2 different spaces in the coordinate plane. Space isn't accounted for. So often when you do these questions, you do things like Pythagoras' theorem. Distance always has to, or Pythagoras' theorem, the length always has to be positive. You ignore the negative answer. But over here we have x plus 1 is equal to plus or minus 4. So to finish this off, we now have 2 answers. We have x plus 1 is equal to plus 4, or we have x plus 1 is equal to minus 4. Right? So we're going to get now x is equal to 4 plus 1 is 5. or we're going to get x is equal to minus 4, sorry, take away 1, that's actually going to be 3. Apologies. And here, take away 1, that's going to be minus 5. So our two answers here are going to be 3, 0, or minus 5, 0. Job done.